now that we have this idea of an expression being true or false, we can use this to help us branch or carry out selection in our Java code or whatever the programming language code is. So inside Moodle, there is an example called if statement examples, and you can download that and insert it into a package in a project in NetBeans. Okay, so the examples in here are based on slides from our Boolean logic slides. Okay, so on page 13, the if statement here. Okay, so selection. Okay, we can change the flow of our program. So a line of code may or may not be executed. Depends on whether the condition before it is true or false. Okay, so there's an example here. We've got a company selling pens at $9.99 each. If an order is placed for more than 100 pens, then there's a 10% discount. Okay, so if an order is placed for 200 pens, then they are not going to cost $9.99 each. They're going to cost 10% less than that, which is basically €9 each. Okay, so in other words, we can't get the cost of the order as either $9.99 per pen or as €9 per pen. It's one or the other. Okay, so both things can't be true. So we need a Boolean expression for that. Okay, now before we look at the code for that, let's just jump over and look at the example. So here it is here inside an appropriate package and an appropriate project. Okay, so the first part of it is basically I am declaring and initializing a Boolean variable called logic underscore variable. I'm setting it to false. Okay, and then if logic variable, now you might think that's a bit strange. How come there's no equal to, double equals, not equal to, greater than, less than, greater than, equal to, less than, or equal to? Okay, essentially, no matter what you have inside your condition bracket after the word if, no matter what is in there, basically it has to just simplify to either the word true or false. Okay, so if my variable already is a Boolean variable and stores false, let's say, then basically this reads if false. Okay, so if false, print out true. Well, that's not true. Essentially, this has to evaluate true. Okay, however, logic variable is storing false, so therefore that condition is not true. So therefore, this won't print out. Okay. We will go into the second half, the other branch. Okay, okay. So our code will be, this line of code will be selected. Okay, system.out print line of false it will be printed out, and that's what's being displayed here. Okay, I'm also using the not logical operator here. Okay, so you can see if not logic variable. Okay, let's think about that. Logic variable stores false. Not logical variable stores true. Okay, so if true, that means the if condition is true, therefore we are going to see F here rather than T, and that's what's actually printed out here. Okay, notice that because I am using the not symbol there, I've got the false part in the, I've got the false line in the if part, and I've got the true line in the else part, whereas here I've got the true and false the opposite way around. Okay, so that's what not does, it inverts. Okay, so let's look at slide 15 then. We've got this code here, I've just copied it and pasted it in. So I'm starting off with the number of pens equal to 0. Okay, I am initializing the total variable to 0. And then I'm calculating what total actually is. So I'm going to calculate, evaluate the right hand side, move the value into total, and overwrite the number 0 in line 27. So number of pens is 0. 0 times 9.99 is 0. So 0 is overriding 0. It's essentially the same. Is the number of pens greater than 100? It's not. It's equal to 0. Okay, so that's not going to happen. Okay, what this is doing is actually it's basically reducing the total by 10%. So the total being reduced by 10%, or another way to do it is to multiply the total by 0.9. Okay, if that's true, in other words, if we have a large number of pens, we should see line 32 being displayed there in if. Okay, as in if inside the if branch. Okay, we're going to print out the total in both cases. Okay, so total is 0. You can see in if is not appearing here. Okay, and that's as you would expect it because the number of pens is actually 0. Okay, so I'm just going to change this and again do experiment with the code. So let's run this here, and this time we should see in if. There it is there. Okay, so 300 by 999 is roughly 3000, almost 3000. 90% of that is almost 2700. Okay, so there we go there, 2697. Okay, so our logic seems to be working here. Okay, moving on to slide 18. We can use some of our more complicated Boolean conditions as the condition in an if statement. Okay, and again, it's just the idea here is that whatever's inside the if condition must evaluate to true in order to go into that branch. Okay, so again, it's always if true, go in and do that code. Else, do some other code, or maybe there is no else. There doesn't always have to be an else. Okay, so here's just if. Okay, so sometimes that's going to happen. Okay, line 29 always happens. Lines 31 and 32 sometimes happen. Line 34 always happens. Okay, if else is different. Okay, if the code is written well, we're either going to do line 40 or we are going to do line 42. And why is that? Because remember, the condition evaluates to true. If it evaluates to true, we are going to do line 40. And if something is not true, it has to be false, in which case we do line 42. So there is no intermediate zone between true and false. We're either doing 40 or we're doing line 42. Okay, so if we just look here at the moment, slide 18, if the age is 5, that's too young to be a teenager. So that's not true. Okay, that is true. Okay, both of them have to be true in order for the and double ampersand to evaluate true. Okay, so the condition is not true. Okay, and then you can go in here and try it yourself. Just satisfy yourself that this time you are a teenager. Or, well, in fact, no, age is greater than 12. Okay, 12 is not greater than 12. Okay, let's put 13 in here and run this. Okay, and this time you are a teenager. Now, I am doing this, you are definitely a teenager. What's that all about? Okay, the condition here, I'm just going to write this in a slightly different way. My line 39. If you look at line 46, what I'm searching for here really is my logic here, my Boolean condition here. I want to use the OR symbol here, okay, the double vertical line. Okay, so what I'm basically saying here, either if either the person is too young or too old, then we are outputting not a teenager. Okay, so notice here the if part, you are a teenager. In this case, the if part, you're not a teenager. Okay, the else part, you are not a teenager for and. the else part, you definitely are a teenager for or. Okay, but when we run it, if our logic is correct, both messages output should be saying we either are a teenager or we're not a teenager. Okay, let's try it with 55. Okay, and you can see both of them are consistent. Okay, slide 27. Okay, this time we've got a range of possibilities. Okay, in the last example we had two possibilities. We had the if branch and we had the else branch. For something like an exam grade, we have a lot of different grades. We have first class honours, 2, 1, 2, 2, pass, and so on. Okay, now the logic here is a little bit flawed, so you might like to think about it. And remember, the idea of branching is that only one of them could be true. So if we look at the conditions, if the grade is 75, is the first condition true in line 56? Yes, that's true. Problem is, second one's also true. Problem is, third one is also true. And problem is, the fourth one is also true. Okay? And the problem in terms of logic here is you want this to basically be evaluated here. But once a true condition in a multiple branch, we could call this a multiple branch if, okay? If, else if, else if, else if. Okay? There's more than one way. There's more than one branch. Okay? So the first branch that's true, the first time the condition is true, basically Java will stop checking in the others. Okay, so you need to be very careful here. So one of the things I'd like you to do is try and make this code a little bit tighter so that only one branch can be true at a particular time. Okay, so you can see here slide 27 is here. Grade is 75 and the first condition is true, so the word pass is going to be printed out. And that's the end. Okay, it doesn't evaluate the others because it's found a branch where the condition is true. Okay, so what I would like you to do is to how can you fix this so that every mark greater than equal to 40 is not treated as a pass? Okay, if the grade is a percentage, okay, how could you amend the code to deal with if somebody types in a negative grade, or if someone types in a number greater than 100, because you can only have 100% and you can't have a negative percent. So see how you get on with that. Okay, do have a go with that. And then one more thing to point out what I'm asking you here is change your double equals to single equals and observe the error. So I'm going to do it here. I want you to try it as well. Once you do that, you can see we're getting an error. Okay, so I want you to be able to tell me next time we meet why there's an error there, why that gives us an error. Okay, and finally, we can use modulus in something like that to check if an integer is even or odd. So we just divide it by 2 and look at the remainder. So modulus 2 means. Okay, so if there's a remainder of 1, we find out the number is odd. Else in this case means nu percentage 2 equals 0. That's essentially what happens. Okay, if the remainder is not 1 when we're dividing by 2, the remainder must be 0. Okay, that's probably gone through everything in the slides. Okay, So I would like you to maybe try and